Welcome once again. I am Nickstar DN. In this video, we will dive into the comprehensive guide on land and topographic surveying and mapping. This field is not only fascinating, but also combines the meticulousness of mathematics, the applicability of engineering, and the aesthetic sense of design to deliver precise depictions of our physical world. The process of land and topographic surveying is essential, as it accurately measures and maps the physical characteristics of a piece of land, including natural formations like hills and valleys and man-made structures. This elaborate interplay of data acquisition and interpretation offers a wealth of information for numerous applications. From city planning to environmental management, we will walk you through every step, from the thorough pre-survey preparation to the field surveying, leading up to the data processing, map generation, quality assurance, and eventually the delivery of the final product. So let's start the journey, beginning with the pre-survey preparation. Before heading into the field, surveyors conduct extensive research and planning. This isn't just about picking up a tool and marching off into the wilderness. It's about meticulous preparation, ensuring a smooth and successful survey operation. Surveyors start by reviewing existing maps, aerial images, and any available records of the terrain. This initial desk study helps them understand the lay of the land and identify key features that need special attention during the survey. But it's not all about maps. Equipment plays a crucial role in surveying. So the next step is to check and calibrate their tools. From total stations to GPS devices, each piece of equipment needs to be in prime condition, ready to record precise and accurate data. This careful planning and preparation stage is vital. It sets the foundation for all the work to come, ensuring that when the boots hit the ground, every step counts. Once the pre-survey preparation is done, it's time to head out into the field. Opening. Once on site, surveyors use a combination of traditional and modern techniques to gather data. Field surveying is a dynamic process that combines the power of advanced technology with time-tested methodologies. It's where the rubber meets the road, or in this case, where the total station meets the terrain. So let's dive into the world of field surveying and understand how the magic happens. First, surveyors establish a network of control points across the site. These points, often marked by stakes or flags, serve as reference locations for all subsequent measurements. It's a critical step that sets the stage for the entire surveying process. Next comes the exciting part, measurement. Armed with instruments like total stations, levels, and GPS receivers, the surveyors measure angles, distances, and elevations between the control points. The total station, a modern surveying marvel, combines the functions of a theodolite for measuring angles and an electronic distance meter for measuring distances. It's like having a Swiss Army knife for surveying. While traditional tools remain relevant, surveyors also embrace the digital age by harnessing the power of GPS. GPS receivers enable surveyors to establish precise coordinates for control points, offering unparalleled accuracy and efficiency. But field surveying isn't just about ground-based measurements. It's also about getting a bird's-eye view. Enter drones, our high-flying friends that capture stunning aerial imagery and topographic data. These flying marvels allow surveyors to map large areas quickly and accurately, providing a comprehensive view of the terrain. Throughout the process, surveyors meticulously record data points, maintaining a detailed log of measurements, coordinates, and observations. This data, often captured digitally, forms the backbone of the entire surveying process. Field surveying is a blend of art and science, a dance between man and nature. It's about understanding the lay of the land, interpreting its story, and translating it into a language we can understand. Data. Closing. After the field surveying, the next step is to process the collected data. Back in the office, surveyors start the process of data cleaning, organizing, and analyzing. This stage, known as data processing, is where the magic really happens. Here, the raw data collected from the field transforms into a coherent and accurate representation of the land's topography. Imagine the surveyor's data like a raw diamond, rough and unrefined. The data processing stage is the meticulous craftsmanship that polishes this diamond into a gem of valuable information. It's a crucial part of the process where precision and attention to detail are paramount. So how does this transformation occur? It all begins with error removal. The data collected in the field is not always perfect. Interferences like atmospheric conditions, equipment limitations, or human errors can introduce inaccuracies. The surveyors use specialized software to identify and correct these inconsistencies, ensuring the highest level of accuracy. Next, the cleaned data undergoes a comprehensive analysis. Here, the surveyors look for patterns, relationships, and trends in the data. This analysis provides a deeper understanding of the land's physical characteristics and helps shape the final representation of the terrain. The last part of the data processing stage is the creation of digital representations. Using the analyzed data, surveyors generate detailed models that visually represent the land's features. This could be as simple as a contour map that shows elevation changes, or as complex as a three-dimensional rendering that provides a bird's-eye view of the landscape. These digital representations are more than just visually appealing images. They are valuable tools that allow us to virtually explore the land, understand its topography, and make informed decisions about its use and development. Data processing is indeed a complex and meticulous process. It requires a blend of technical expertise, analytical thinking, and creative problem-solving, but the result? An accurate, detailed, and insightful depiction of the land that brings the physical world into the digital realm. Once the data is processed, it's time to generate maps and reports. This next stage is where the processed data gets translated into practical, usable information, but more on that in our next scene. Stay tuned. With the processed data in hand, surveyors generate maps and reports that provide a detailed understanding of the surveyed area. This is the map production phase, one of the most critical stages in land and topographic surveying. It's here that the raw numbers and coordinates gathered in the field are transformed into visual representations. These maps are not just ordinary maps. They're intricate and precise depictions of the land's physical features, offering a bird's-eye view of the terrain. The map production process involves the application of cartographic principles to ensure that the maps are easy to read and understand. Surveyors carefully select the most appropriate symbols, colors, and scales to represent different features and elevations. There are several types of maps that can be produced, each serving a unique purpose. Topographic maps, for instance, display the shape and features of the land surface, including contours, hills, valleys, and bodies of water. Cadastral maps, on the other hand, show property boundaries and land ownership details. These maps are not just pieces of paper with lines and symbols. They are essential tools used in a wide range of fields. Urban planners use them to design cities and transportation networks. Engineers rely on them for the planning and construction of infrastructure. And environmental managers use them to monitor changes in the landscape and develop conservation strategies. Before finalizing the maps, it's time for quality assurance checks. Quality assurance is a crucial step to ensure the accuracy and reliability of the maps. This phase involves meticulous tasks aimed at validating the data collected during the survey. As a part of this process, surveyors compare the newly surveyed data against existing records. This comparison helps identify any potential discrepancies or anomalies that may have occurred during the field survey or data processing stages. In addition to data verification, on-site inspections are also conducted. These inspections allow surveyors to manually verify the key features mapped during the field survey. This double-checking process ensures that the data is not only accurate on paper, but also accurately represents the physical world. These quality assurance checks are not just a formality, they are an integral part of the surveying and mapping process, ensuring that the final maps are not just visually appealing, but also scientifically accurate and reliable. Once the maps have passed quality assurance, they are ready to be delivered to the client. Once approved, the final maps and reports are delivered to the client. These aren't just any documents. They are a treasure trove of information, a window into the very characteristics of the land. They serve as an invaluable aid for land developers, government agencies, and anyone involved in land management and development projects. These final deliverables, they don't just mark the end of a surveying process, they kindle the beginning of informed decision-making. And that concludes the process of land and topographic surveying and mapping. We've now covered the entire process of land and topographic surveying, from pre-survey preparation to the delivery of final maps and reports. We've seen how surveyors meticulously plan, gather data in the field using advanced tools and techniques, and process this data to create accurate representations of the terrain. These maps, rich in detail, serve as invaluable resources for a multitude of sectors, including urban planning, engineering, and environmental management. The process doesn't stop at map production, though. Surveyors ensure the highest quality and accuracy through rigorous checks and validations. This comprehensive approach, combining art, science, and technology, is what makes land and topographic surveying such a fascinating and crucial field. It's not just about mapping the physical world around us, but about understanding it, interpreting it, and using this knowledge to make informed decisions. Thank you for joining us in this comprehensive guide. We hope it has provided you with a deeper understanding of land and topographic surveying and mapping.